Write each expression as a single logarithm. All right, so before we were expanding logs, now we're condensing them. So basically we're going to try to write this as a single log. And when we look at the first one in example A, we have 1/2 log of x minus log of y plus log of z. First thing you always want to do is work from the exponents and put the exponents back as exponents and no longer as factors out in front. So in other words, this 1/2 should come up and become the exponent of x. So any coefficient there in front of a log should be written as an exponent. So we're going to write that as log of x to the 1/2 power. Now, you might remember that a 1/2 power is the same as a square root. You could jump right to that if you want. That's up to you. Then we have minus log of y plus log of z. Now, from there, we can say that this is log of x to the 1/2 power is the square root of x, right? Minus log of y plus log of z. Since all of these logs have the same base, and by the way, that base is 10. If it's not written, it's assumed to be 10, so it's the common log. If all the logs have the same base, you can use the properties we have before, which said that, so remember something like this, right? Sums can be written as products, and differences can be written as quotients, right? Okay, so this first difference can be written as a quotient. In other words, I can say that that's log of the square root of x over y. So I keep the log, and I perform the division there. All right, then lastly, we have this plus log of z, right? Plus log of z. And that can just be written as a product, right? So we're going to be able to say that we'll have log of z times the square root of x over y. And that's it. That's a single log that represents that original expression that was expanded out. All right, from here, let's look at example B. So for example B, it looks like we have a difference, right? So we'll certainly be able to write a difference as a quotient as long as we have the same base, which we do, right, for both logs. So first thing we want to do, though, is take care of any exponents. So any coefficient in front of a log can be written as an exponent. Let's go ahead and do that. So we're going to end up saying that this is log of x squared plus 4x plus 3, right, base 5, minus log of x plus 3 quantity squared base 5, right? Then from there, that difference can be written as a quotient. So we're going to go ahead and write that as log base 5, and we're going to have this complicated piece here. X squared plus 4x plus 3 divided by x plus 3 quantity squared. All right, so we're taking the log of all that. Now that's already a single log. However, it might be prudent to go ahead and simplify it from here. We can probably do a little simplification here. So what I mean by that is we could probably factor, right, that expression a little bit. So let's factor the numerator here. X squared plus 4x plus 3. Well, if I factor that, we're looking for factors of 3 that add to 4, right? Factors of 3 that add to 4. Well, that would be 3 and 1, right? So it should be x and x plus and plus 3 and 1. And the denominator is x plus 3 squared. That's just x plus 3 times x plus 3. And then we can actually cancel that out. So it becomes a little bit simpler. Our final answer becomes the log of the fraction x plus 1 divided by x plus 3 base 5. And that's it for that one. All right, let's take a look at our last example, example C. So any exponent again, or any coefficient should be written as an exponent. But to do that here, if we try to bring this 2 out in front, up here as an exponent, which we can do, it's going to be a little awkward at first. Let's write it out. It'll be ln of the cubed root of x quantity squared, right? So that's a cube root of x there, squared, plus ln of e times x squared minus ln of e squared. All right, I can certainly rewrite that a little bit. The x can be written with a rational exponent of 1/3 here. I can write it as ln of x to the 1/3 power quantity squared. I can do that because remember the third root of x is the same as x to the 1/3 power. Then I'll have plus ln of e x squared minus ln of e squared. Okay, let's continue here, laterally here. So it'll be 2 distributed in here to make it ln of x to the 2/3 power, right? Then we'll have plus ln of e times x squared, right? And then we'll have minus ln of e squared. Well, let's go ahead and rewrite that first sum here as a product. So we'll have 1 ln, and then we just multiply the two pieces. Then we'll have e x to the 2/3 times x squared. What happens when you multiply things that have the common base? You keep the base and add the exponents, right? So it'll be minus ln of e squared following this, but then we can go on to say what? That ln will become ln of e times, what happens when you add these exponents and keep the single base? What's 2 plus 2/3? Well, let me just work that out for us here. Remember to be 2 over 1 plus the 2/3. You have to get a common denominator. That would be 3, so it'd be 2 plus. To go from 1 to 3, you had to multiply by 3, so it'll end up being 6, right? Because 2 times 3 gives you 6. That'll end up giving you 8/3. So the exponent on x here becomes 8/3. Okay, so I've rewritten this here, and then we have that minus ln of e squared. Almost done. Last step is to turn this difference into a quotient. So it'll end up being ln of e times x to the 8/3 power divided by e squared. And then finally we can do a little cleanup here. Ln of e times x to the 8/3 over e times e, right? Because e squared is e times e. Cancel out those e's a little bit, and you end up with ln of x to the 8/3 power divided by e. Now that would be great, except for you have an option here. That ln of e can be simplified a little bit. So we could actually, and we could have done this right from the beginning, but you can actually expand this out. Even though we weren't planning to expand any further, really, we wanted to do what? Just really simplify. You could actually expand this by saying ln of x to the 8/3 power minus ln of e, right? Because it's a quotient, we can write it as a difference. And you may say, well, why would we want to do that? We're supposed to write it as a single log. Well, simply because ln of e is just a fancy version of this property, right? Because ln is log base e, and so if you take the ln of e base e, it should just be 1. That means we can just say that all of this is just 1 there. So the final answer of this would be ln of x to the 8/3 power minus 1. In my opinion, that's probably the best way to write it. Not that this is a lot different from what we had here, but I like to have the one, I hate to see an ln of e not simplified. And I think most faculty members at universities would agree.